In this lesson, we will formalize the computation of scores that we've seen in the previous examples using risk equations. We'll also look at interaction terms and why they're useful.
The prognostic models we've seen so far express score as a sum of a feature times the coefficient associated with that feature. For example, if we had the age feature, we would multiply it by the coefficient associated with age, and repeat that for other features like the blood pressure, and then sum up all of the contributions to get a sum score. This is what's called a risk equation. Now, the risk equation doesn't need to be linear in the features themselves. They can be linear in the natural log or in log base 10 of the features, like we saw in the MELT score. Finally, risk equations can also include interaction terms like we saw in the ASCVD risk example, where we might have two features that are multiplied with each other and then further multiplied by a coefficient that is associated with the product. Let's take a deeper dive into understanding what these interaction terms do. To understand interaction terms, let's take a look at risk equations without interaction terms first. Let's say we have a risk which is dependent on the natural log of the age and the natural log of the blood pressure. We can graph the risk as a function of these features with the natural log of age on the x-axis and the natural log of blood pressure on the y-axis. The risk is represented by the colors, where yellow is greater risk than green, which is greater risk than blue. Without interaction terms, if we were asked about the relationship between blood pressure and score, we would say that as blood pressure or the log of the blood pressure increases, the risk increases. We can see this by simply fixing an age. So we have the yellow line fixing an age and looking at how the risk is changing as the log blood pressure is increasing. We can see moving from bluish green to light green, so the risk is increasing. Now let's see what happens with interaction terms. Now here's the risk equation with interaction terms. Notice that we now have a new term which is multiplying the natural log of BP with the natural log of age with the coefficient associated with this product. Graphically, we have an interesting picture going on. With interaction terms, if we were asked about the relationship between blood pressure and the risk score, we would say that it depends. Let's fix the age and look at how the risk changes when the blood pressure changes. On the left, we first fix the age, the log of the age at 3.8, and we see that the risk is increasing as the blood pressure is increasing. But on the right, when we fix the age, we see that the risk is staying the same, staying in the yellow band as we're increasing the blood pressure. So here are the graphs without and with interaction terms displayed next to each other to see how interaction terms can capture a dependence between variables. Without interaction terms, the effect of the two variables, blood pressure and age, is independent. Whether you are young or whether you are old, blood pressure is affecting risk the same. As blood pressure goes up, risk is going up. But with the interaction term, blood pressure is having less of an effect on risk when the patient is old than when they are young. Now that you're familiar with prognostic models, risk equations, and how interaction terms change the relationship between the variables and risk, let's look at how we can evaluate a prognostic model.